Hello guys, welcome to this live stream. In this live stream, we will continue our customer personality analysis. So let me open my VS Code and open my customer personality analysis directory. Here you can see we have our dataset and we have our notebook file. So let me give you a quick recap what we have done yet. So we imported our CSV file, then we do some EDA, then after that what we have to we remove some unwanted you can say unwanted columns. After that we converted categorical values into you can say numeric values by using one hot encoding. Then we created a correlation heat map, and then we splitted our data into X and Y. And for balancing our data set, we use mode. Then we splitted our data into training and testing set, and then trained our model for using random forest classifier. And after that, we calculated accuracy score, created confusion matrix, and created classification report. Then after that, we performed standardization, and after performing standardization, we trained our model using SVM and you can say logistic regression algorithms. So now what we will do, we will train our model for all possible, you can say, all, not all algorithms, you can say mostly quite a few are in this, you can say list, and we, you can say, find the best fitted model for our problem. Let me open the, so I use in home price prediction. And for after you can say finding best fitting model, we will head towards our visualization part. Let me import these all necessary libraries. Then let me import this algorithm, all algorithms. Then let me also copy this code. So we need to import shuffle split also. That is in model section. Now let's so here we are using linear regression model, lasso model, ridge model, decision tree regression model, SVR, that is SVC, you can say, not SVM, that is spot vector machine. Then we have random forest regressor, then we have gradient posting regressor. Let me run this code also, and okay, I'm really sorry. We need to start from scratch. We need to run our, you can see, command from this part. You can see it start running. Here you can find getting such a low score. Oh, I'm really sorry. It is a classification problem, not a regression problem. Uh, it's my bad. Let me go to type T's prediction. Here I use that. You can see, and from this you can see dictionary. We will remove multinomial naive because it takes just positive values. But in our X, we have negative values, so that's why we need to remove this. Now let me go to the libraries part. Here you can see we need to import all these libraries. Let me give one down also. Now till it run, and let me give finding best fitted model. We do not need PCA. We already imported classification report. Also, we don't need multinomial, and we also don't need this train test split. Also, we don't need this crosswell score. Let's see. Here you can see we are getting 88% accuracy using logistic regression, and yes, we are getting maximum accuracy using logistic regression. So I think we already trained using logistic regression, but why we are getting around okay. So we are getting 72% because we are training using X trained and Y trained. But in this situation, we have trained using X and Y. You can see, and we used shuffle split here. That's why this is giving me around 88%, 0.88 accuracy score. So we can do one more thing. Let me give some another random state, and let's see. Still logistic regression give us the, you can say, best score or not. You can see we are getting again 0.87% accurate, 0.87 you can say score. Now we can see random forest giving us also the same score. So we can take let's see, we fitted for random forest also, and it's giving me accuracy around 87. And let's check its F1 score. It is around 0.88 and 0.88. Let me check it for logistic regression. Here you can see the score is decreased. So we will, you can say, we will continue with our decision forest. So let me remove this, and we will continue with our random forest classifier also. Now try to hypertune this model. Let me do one thing. Hyper tuning our best fitted model. And one more thing, we again need to, you can see, again need to define our extend and access, because here we done standardization, but when we are using you can say when we are using a random forest classifier, there is no need to use standardization, because it works on if else condition. That's why. Let me give here accuracy score. Then this is the classification report. So before training this, we need to again define our extended. You can say we need to again run this command. So it is run. Now we can hypertune our model. So for hypertuning, we have you can see this criteria as our hyper parameter and an estimator as our hyperparameter. So let me do it for, you can say, entropy criterion is equal to entropy. Let's see what score it will give. So again, it is giving me around 0.88 and 0.88. Let me do it for now log loss. For log loss, let's see what accuracy score it will be now. Here you can see F1 score is decreased now. So let's continue with our Guinea, and by default, this criteria will take Guinea, or you can say work on Guinea. Now we will do n estimators. Let's take 100 n estimators. So it will you can say take or you can say train 100 decision trees, and then it will you can say it will you can take all the results from that decision tree, and then uh, which you can say which category gets the maximum number of votes, then it will give that categories as output. So in this case, it trained 100 different decision trees. So here you can see we are getting 0.87 as our F1 score. And I guess by default it takes 50. Let's check. Let me do it for 20. Let's see. Here you can see our F1 score is increased. It is around 0.89, and for 0 it is 0.88. Let's do it for 10. I guess in this case our you can say F1 score will be decreased. You can say yes, it is around 87. Let's do it for 25. Let's see how it perform. Here you can see again we are getting around 0.8840 and 0.89 F1 score for 1. So we will continue with this, and now what we will do, we will save our model using pickle. Saving our model, import pickle, and then I forgot the code. Let me just and our model name is forest. And let me do one more thing. If anyone start run, you can say run this entire notebook, then it will you can see. And after this, we will again define this external access. Nice. Or you can say we will give this as model. Now let me delete this forest.pkl. Now let's head towards visualization part. So we do visualization before one-hot encoding. And we can do one more thing. We start our visualization from here because we will take use of this Z cost contact and Z underscore revenue column also. That's why. Again, let me do one more thing. We need to again run this. You can see. Again, define df So let's start our evaluation. So first we will do histogram or a bar chart showing the distribution of customers by birth year. Here you can see we have a column name year birth. So let me do birth year distribution. So for that we can create a histogram. Uh, for we will use seaborn hist plot, and we will give data as df, and in df we have a column name as that is birth year. It is with underscore or it has year birth. And then let's check other parameter also. Let's give all other parameters as default. Then PLT title. Here we give our title, that is birth year distribution. PLT.text label as year, and PLT.y label as count. Now let's do PLT.show. Here let's see. Here you can see we can do one more thing. We can convert birth year into age also. Let me do one thing. Let me do KD is equal to true, so we get a smooth line also. You can see we are getting a smooth line also. It seems really nice. Here you can see we have maximum number of people around 1975. You can see around 1970 to 1975. Let's move to our, you can say, let me move this cell to here. Also this cell to here. Now we move towards our next distribution, that we can create a pie chart of, we can create a pie chart of our education column, because it has different categorical values. so we can check the percentage uh, how the education is distributed. Pie chart of, you can say, a education column, and we have to give this in a, you can say, heading. For that we will, I guess. So matplotlib has pi chart as pi. Our x value is our df of, you can say, education. Plt dot title, education distribution. Plt dot show. Let's see why we are getting error. Could not convert string to float, dative graduation. Oh, I'm really sorry. Inside this, we need to give value counts. I forgot to let me df dot education dot value counts. You can see we need to give this data, and this is as our category. So we can do education dot value counts, and then after value counts we will do values also. And if we do use values method, let's see. So here you can see, yes, we get our values. And for label, I guess there, for labels we will use tf of education dot value counts, and here we will use dot index, because our index part has, you can see, label. You can see in index we have our labels. Let's see. Here you can see we can do one more thing. We can display our percentile also. Let's check for. uh, Here you can see, I think this is the parameter auto PCT. We will define our, let me check. Let me do plt.py, and if we need to display numeric values, then okay. Here you can see we have our auto PCT as %1.1 F %%. Let's copy this and paste it here. Here you can see we get a nice visualization. So we have around our 50% customers are, you can say, have a have a graduation degree, and our 21% customers have a PhD degree, and around 16.5% customers are, you can say, have master's degree, and around 11.5% persons have basic and second class degree. So now what we can do, so we created a education distribution similar in this way. We can, you can say, create a marital status distribution also. So let's do the marital status distribution. Pie chart of marital status distribution. So okay, let me copy this column name. So we have to do here. Let me create a new cell. We have plg.py. Again, our df square bracket marital status dot value counts. Then for data we need to give as our values. Okay, and then in labels, uh, again we have to define our df of marital status dot value counts, and here we need to give our index, and then for you can say percentage we need to give auto PCT, and then that is percentage 1 dot percentage 1 F %%. Or I guess there is no percentage. For let's check. Here you can see it is percentage 1.1 F %%. Here you can see. Now again, let's give a title also. It is our marital status distribution. Now we will give plt.show. Let's see. Here you can see our 38% customers are married, and 25% are together, and 21% are single, and 10% are, you can say, divorced. Let me do one more thing. Let me check how many unique values in this you can say marital status column. So we have married, together, single, divorce. So we have widow. Okay, then in 0.1% we have alone, absurd, and YOLO. uh, can we what we can do now, is it correct to give this in a single column, alone, absurd, YOLO? I think We cannot combine this in a single column. Let's forget it. Now head. Let's head towards our let me charge by PC. Here now what we will do, we will create a histogram for our customers income, or we can create a bar plot also. Let's see. uh, Customer income distribution. We will create a bar plot. For that we will data is our df and x is our customer. So let me check how the income you can say column is defined. PLG.title, income distribution, PLG.available as count, then PLG.show. Okay, we are getting values like this. Let me create a his plot. Here you can see. But what's the problem in bar plot? Let's try for again bar plot. Let me remove for this X label and Y label also. Okay, so we can let me do SNS dot bar. let's see. I think we get you can say room visualization. I think for bar plot we need to you can say define a, bracket or so for that you can see we are getting the visualization. Let me remove this. So let me increase its size using fill action is equal to fixed size. Fixed size as we can 7 comma 8. Let's see. Oh, I'm sorry. It should be 8 comma 10. No, 10 comma 8. So we can see. Also, let me do KDE is equal to true. Oh, this must mean this plot. Here you can see our data is right skewed. Uh, Now what you can do, let's check next column. So we have kid home, kid teen, kid home and teen home. Let's repeat this. Let me check how we can. Is there some kind of framework or not? Now, what we're doing, we are creating a stacked, uh, you can say, stacked bar chart. Kid home and teen home distribution. So here we will give for teen home, comma, kid home. Let's see. Yes, we need to add one square bracket also. You can see. Let's see how what type. I guess dot stack is just okay, get a very paragraph. Let me do df kid home dot value counts, and then df of team home dot value counts. And now what we will do, we will combine this data and create a third, you can say another data frame where our index will be 0, 1, and 2, and uh, now let me create a node df home home k d, or you can say kt, pt dot data frame. In this data, we will give first our dot values as list, and as a second list we do dot values, and then after we will define our index. So our index will be 0, 1, and 2. Right. Length of values do not match length of index. So our index will be kid home and teen home. Let's see if we create a data from like this. And then try to calculate value counts. Dot transpose. Or let me give this in array. Array. And then takes its transpose. Now let's try to reshape this. with 2 comma 3. 3 comma 2. No, we are getting wrong results. Transpose of a array in Python. So for that we have dot transpose. Transpose, and this is the method. Okay, so now we are getting the results. Okay, nice. So we need to give this code here, and in index we need to define, we need to give 0 1 2, and in column we need to give you can say first it is kid home and then it is teen home. Column we need to define this list. Then first is our kid home, then teen home. Let's see, here you can see we get a nice data frame here. So let's plot this. You can say plot this time stacked is equal to true, and then what we have to do, we need to give kind is equal to bar. Okay. Kind is equal to bar, and then color will be let's get give the default colors. Oh, we need to add comma also. How can we add? Here you can see we get another get the results, but can we give the with label? Okay, so let's move forward towards our next visualization. Let's see. Let's check our next column. So we have next column as recency. So we can create a histogram or a bar chart uh, showing the distribution of you can see recency of customer purchases. Oh, we forgot to add title here. Oh, yes. Just add. Send a bar chart of it. Our X level will be Y level will be. You can see get it. So let's check its length. So we have 100 unique values. Then we need to create a histogram for this. For histogram, we do essence dot is what the data will be df and x-axis will be, you can say, recency. KTE is equal to true. Histogram of the recency of, so you can say, purchases. Belt.x label as method y label as count. Here to do show. Let's see. Here you can see we get results. Let me duplicate it is equal to false. We can see. Now let's move forward with our next visualization. Let's check. You can see next column. So we have uh, main MNT. You can say wine, fruits. So let's take all columns. From that, we will get some of all spendings on wine. Then same this we can do it for fruits category. Various product categories. And let me define new df p underscore cat is equal to pt dot data frame, and in this data frame we will give values as df of mnt. First we will calculate for wine dot sum, and in same fashion we will do for other 5 categories also. 2, 3, 4, and 5. MNT fruits, MNT meat products, MNT fish products, sweet products, Forget. Again, let me do one thing. TF4. So if we do it's some, let's check what we will get. If we will do some now, here you can see we get our results. Again, we will create a bar plot for this. Dot values, comma, y as our dot index, or let me do one thing. For y, we will do this, and for here you can see we can plg to title. And I guess there is a command for rotation. Let's do one thing. Create a full counter. You can see we getting here a nice you can say category. Okay. Now let's move forward with our next visualization. Number of deals purchases, number of web purchases. So okay, we have different types of purchases category here. So we have values from 0 to 15. So how can we let me just do one thing. To I can say various channels. And what we will do, we will do we will create four different subplots. So in our first plot, just group deals. Yes, it starts from zero. After that, we need to give axis 0, comma 0. Dot set title. It is X tick or X label. Uh, In same fashion, uh, we will do different categories. Now we'll do it 1 comma 0 and catalog purchase. You know, most of our purchases. You can see. Okay, so it is set X level. Okay, let's see. So let's look at this title because this is creating confusion. One comma one. Now instead of two purchases, we will use web purchases, catalog purchases, store purchases. Here you can see now we are getting a nice visualization. Now let's move forward with our next visualization. Uh, Next we have a column name, number of web visits per month. Okay. Visits per month. Essence dot. Let's this time use prt dot his plot. It is dfo. What's the column name? It is number of and here let me do. Then it is count. We have to dot show. So let me use sns dot hist. Once this is written, you can say step. So this plot where data will be our TF and column next will be. Here you can see that's the nice visualization. What if we print this? from 1 to you can say 26. So we have 11. And for 1 we have 150. Yes, around 153. What will we do? So maximum value is 20. So 1 to 21, and the labels will be range 1 to 21, and then to usually. So for 0 we have this, and for 1 we have this. So 3, okay. So we are getting our visualization. Okay. Now let's move to towards our next visualization. Let's see, can we create here a single title? Purchases made through various channels. So it goes to, you can say, last visualization. What if I give this as an axis? I get an error. Okay. Now, uh, so we have this. I think for this we will continue our visualization for tomorrow. This is enough for today. For these columns, we will create a visualization tomorrow. Let me just, you can say, save these notebooks and add it to my Git. Day 2. Okay. So these are uploaded. You can visit on my, you can say, GitHub. There you can use this. You can say GitHub. That is a customer. This report that is customer personality analysis. Thanks for watching. Thanks for watching.